Hi folks, in this video we continue our practice with formal proofs in first order logic. This goes with the previous video, the one of two, where you're doing a similar proof. There's just a slight twist to this proof. Previously your premise was this sentence over here. It was an negation around an existential around a disjunction. What I've done is I put this inner part into its Boolean, or its conditional form, using the Boolean definition for the conditional, and I put this as an arrow. Now I know I told you when you're translating things from English, never translate an existential around an arrow. Okay, so I know this is a really ugly form, but it's not like this is syntactically impossible. It's just not something we would ever say in English. But in terms of a formal proof practice, I think it's really enlightening. So forget about the fact that we're not translating this or anything. Just imagine you're trying to do the proof like you did in the previous example, but with one small twist, that this is a different symbol in here. So pause your videos and see if you can figure this out in light of what you learned from the earlier video. Okay, let me just repeat the things I said, the things that I notice immediately when I look at this proof. I see it's a negation around an existential. I know that's an annoying pattern, but I know it's not the most annoying pattern because I can deal with that. I'm just going to have to build this thing from the inside, but I know building the existential is less annoying than building a universal quantifier. Also, my conclusion is a universal quantifier, and that makes me happy. I love universal conclusions because I know immediately what to do. I box a constant. Now, what you do next on line 3 is that you have to assume not P of A. And again, how would you know that? You can't just make this up out of thin air because that doesn't, line 1 doesn't tell you anything about that. You would never know to do that next unless you are thinking about it from both directions. So when I box that constant on line 2, you must formulate down here on the penultimate line what you want inside the scope of the universal quantifier. I want to prove that A has property P because that's what my goal is, my conclusion. The syntactic structure of my conclusion tells me what goes there. That, again, is what tells me to do this on line 3. It's because I'm doing a reductio of that thing. And why do I need to do a reductio? Because there's nothing else I could do. I can't do any rules to this. I can't apply existential elim to it because it has a negation around it. And I can't apply any rule to line 2 because there is nothing on line 2. It's just a box constant. There's no formula there even to apply something to. Okay, now, what do you do on line 4 now? Now you assume P of A. And you might be wondering, how the heck did you know to do that? What tells me to assume that there? Just because it's the opposite of that, why would I assume P of A if I'm already assuming not P of A? That doesn't make sense. Well, let me say, the only reason why I knew to do that was because I was thinking from both directions again. When I know my goal is not when I know my goal is P of A on this line, the second to last line, and that's why I assumed not P of A, I know that my goal down here is a contradiction symbol. So you should have sketched that out in your minds already. And then you can also think, how am I going to get that contradiction symbol? Remember how we deal with these patterns. We have to build this thing from the inside. So the line that goes above that is going to be that existential, the thing inside the scope of the negation symbol from my original premise. So I know this is my goal. And of course, you got to keep going. How am I going to get this thing? You know it's by existential intro. So I have to have some previous line that has P of A, arrow Q of A, and I get this by existential intro. So that tells me I need this on this line. And of course, now you know how to prove arrow sentences. This is where your knowledge from the first half of the course now needs to be second nature. As soon as you get this far, you've got to know what to do. You assume the antecedent and you get to the consequent. I love proving arrow sentences because it's so easy. You know what to put in the subproof. I just get another premise. So the reason I assumed P of A on line 4 is only because I went through this complex series of reasonings. I'm 6 lines deep from the bottom of my proof. You have to be thinking about it that way in order to have any idea what's going to be going on line 4. If you just stare at lines 1 through 3, they're not going to tell you what to put on line 4. Now, once you get this far, though, now the proof practically solves itself. You just have to remember one little trick. I know P of A. How do I get to Q of A? Well, don't forget, you also know not P of A. If you're not going to make use of this assumption on line 3, your proof is not going to be valid. It's only because you're actually going to use this information on line 3 that the proof actually works. So what you have to do here, what I'm sort of telling you is remember from prop these things I called the reiteration trick and the contradiction trick. Well, here we're using simply the contradiction trick. Okay, let's back all the way up and just see how this works from the beginning. How would we justify the following line? Well, I'm doing the contradiction trick, so I'm using contradictions on line 3 and 4. And of course, we know already that I want Q of A. How do I know this is what I do contradiction elem for? It's only because of that complex process of reasoning that we did and read previously. That we know why we wanted that cue now, because we're going to just do arrow intro with it. And after we get that, that's the basis of our existential. Now the proof is just sort of falling into place the way we've already talked. That's the basis of my contradiction symbol here. That finishes my reductio, the thing I started on line 3. That finishes my universal proof, the thing that I've known I'm doing all along. So I think it's really instructive to compare how this proof goes in part 2 with the previous proof in part 1. At a broad level, structurally, they're incredibly similar. All that differs is the little details that you have to do in the middle here, because the inner structure of this is different. But see the ways in which these proofs are common, are similar, and are different. And I think that really helps you understand the how proofs in FOL work. Okay, thanks.